So we are going to look into polynomial functions. Specifically in this video, we're going to look at graphing quadratic functions. Quadratic meaning degree 2, so the highest exponent that you see in the polynomial is a 2. So I'm going to start with an example here showing you how to find the vertex when a quadratic is in this form. So this is just function notation. F of x equals 1/2 x squared plus 3. So that's like having, this is like a y. And we're going to find the vertex and then plot 2 additional points. Anytime that you have an equation in this form where you have something times x squared plus a k value, this k shifts up or down. And in this case, it shifts up because it's plus. And if it was y equals ax squared minus k, then this would shift down. And it's because it's related to this y value, and your y value is the change vertically. So if you're adding to the ax squared, it'll go up, and if you're subtracting from it, it will go down. One thing to note is without this k, the y-intercept is 0. If you plug in 0 for y, you get 0 for x and vice versa. So it does cross through the graph of ax squared. The vertex, or that middle point, is at 0, 0. So the vertex, going back to that, the vertex is the point around, it's either the minimum or the maximum of a parabola being the shape of a quadratic. So a quadratic looks like a U or an upside down U, and we'll talk about the difference between those as well. The vertex is right here, and the graph is symmetric around that vertex, and that's called an axis of symmetry, that dotted line I drew. So all of our graphs that we graph will have that shape. They might be skinnier, they might be wider, they might be upside down, but they will have that shape. So what we're going to focus on here, again, is this shift up or down. And this one shifts up. So again, if you have, this is a very rough graph, but this would be the graph of x squared. So if we're adding 3 to that, it literally just goes up by 3. So we know that the vertex of this graph that we're trying to do here is at 3. All right, because it's taking that shift up. So anytime you have that plus 3 or minus whatever, it's shifting up or down based on that number. All right, so that gives me the vertex. That gives me 1 point in my graph. Now with a line, you just need 2 points because that's all you need to get that line through there. With a parabola, we need the vertex and we need at least 1 point on either side of that. I always recommend to get at least 2 on either side of that, just to kind of as a check to make sure that you're doing the right math and getting the right points there. So what we're going to do is we're going to pick 2 points on either side of that vertex. The vertex, that point is 0, 3. So I'm going to make my 0, 3 in the very middle of my table and then pick 2 points on either side. Again, this is because it's symmetric, and you can see that it's symmetric about that point, so you need points on either side of that. The easiest thing here would just be -2, -1, 1, and 2. And then it's just a matter of plugging directly into that formula here. So we have 1/2 times -2 squared plus 3. I'm just plugging in this -2 into our equation. And so -2 squared, that would be a positive 4 times 1/2 plus 3. And 1/2 times 4 is 2, plus 3 is of course 5. All right, if we do -1, we're going to get 1/2 times -1 squared plus 3. And that will be -1 squared, again, order of operations to do the exponent first. -1 squared is 1, so you get 1/2 plus 3, which is 3.5 or 3.5. So when we plugged in -1, we got 3.5. We go a little bit more quickly through this next part, but if you notice, the next ones are just 1 and 2. So if I take the negative off of the 1 squared is 1, times 1/2 is 1/2, plus 3 is 3.5. This makes sense because this is a symmetric. It's the same, the point over here will match that y value over there. So it makes sense that you'll be getting a mirror image here. And just like with this one, if you take the negative off the 2 squared is 4, times 1/2 is 2, plus that 3 is 5. again, makes sense. And this is why I recommend doing 2 points on either side, because if you end up getting different values, something's going wrong. As long as you've gone the same distance away, you know, like the difference between all of these x values is 1. So as long as you keep that at the same interval, this should be symmetric about the vertex. All right, so then it's just a matter of plotting these. So we're going to put these on here, and we just want to get the shape of this graph. Yours will look a lot prettier in Alex, but we're going to get -1, 3.5. So -1 is here. 3.5 I'm estimating. Sometimes this is hard when I'm up close to get this right, but -2 is 5, so up here, hopefully that looks right. And then 1, 3.5. Again, it's mirror image. Oh, it's a little high. And 2, 5. And you can see that we do get that U shape. And that's the shape, that's our graph. So in order to find the vertex in this form, notice that there's no x term, it's just an x squared and then a shift up, or if it's down, you can just find that vertex pretty easily and go from there. All right. So we're going to look at one that's a little bit harder, it's not in that form. So let's say that we have see some examples like this where it says take this and we want to write in vertex form and graph. All right, so vertex form is it just looks like this. So vertex form, I'll write this down here. It looks like f of x equals a times x minus h squared plus k. So it's kind of like that previous example, except we have something going on with that x. Like it's not just x squared, it's x minus or plus something squared. So this is vertex form where hk is the vertex. All right, so I need to get this in this form. There are 2 ways to do this. One way is completing the square, which is kind of complicated. We haven't talked about that in these videos up to this point. The other is to use a simple formula to find the vertex. And to find the x value of the vertex, you can use this nice little formula, or -b over 2a. And this is using standard form, where it's in, this is where the a and the b are coming from. So this is in standard form. So you can look at standard form and get your a, b, and c values. It's just the coefficients of the x squared, the x, and then the constant term. So in this case, your a is 2, your b is -4, and your c is 5. So what I'm going to do is I'm going to find the x value of the vertex, and then find the corresponding y value, and then I know the vertex, and I can just plug right in here. That a value is just going to be the 2, just like it was in the standard form. So it'll be pretty nice. So we know that our a, I'm just going to list out this, our a is 2, because we need to plug into this formula, so we need a, h, and k. So those are the things that I need. So a is 2, I can just look at that and see, because it's the same here in this form as it is in standard form. Then I'm going to find -b over 2a to find the x value of the vertex. So x, which, and actually, because we're looking at vertex form, the x value of the vertex is h. So I'm going to look at this as h is -b over 2a. -b will be the negative of -4 over 2 times a is 2. So this will give me +4 over 4, which is 1. So there's my h. All right, then my k is just going to be the corresponding value. So like it's the corresponding y value. So if you go back up here and just take this h, so it's the h, it's the corresponding value for this h of 1. So we take that 1 and plug it in here, and we're going to get 2 times 1 is squared minus 4 times 1 plus 5. So I'm just, again, finding the x and y coordinate for that vertex. The x is my h, the y, corresponding y is the k. So I've got the x value of my vertex using this formula, and then I just plug that in here to find the corresponding y value, which is what we're going to plug in for k in the vertex form. All right, so 2 times 1 squared is just 1, minus 4 times 1 is just 4, and then plus 5. So 2 minus 4 is negative 2, plus 5 is 3. So that's your k value. That's enough information to plug this in. So I can write this as y or f of x, they're interchangeable. And I'm just going to put in 2 for a, again this format, x minus your h, which is 1 squared, plus k, which is 3. This is vertex form of this equation. So this is taking this and writing it in vertex form. We're going to use that to help us graph. The graphing part of this, you don't really need it to be in this form to be able to graph it. I'm going to leave it there because I'm going to talk about a couple of different things as we go through the graphing. But really what you need, the biggest thing that you need to graph is the vertex. If you have the vertex, then we can use that table just like we did in the previous problem, find 2 points on either side of that vertex. So that's what we're going to do in this example. So I know that the vertex is 1, 3, so I'm going to pick negative 1 and 0 and 2 and 3 over here and use that to plug in. So I'm going to do this kind of quickly. I did the previous example, showed you out the whole thing, but I'm just going to plug this in. Negative 1 minus 1 is going to be negative 2 squared is 4 times 2 is 8 plus the 3 is 11. I plug in 0. 0 minus 1 is negative 1 times 2 is 1. I'm sorry, to the second power is 1 times 2 is 2 plus the 3 is 5. Notice that if you plug 0 in, it's actually easier to plug that in up here because 0, this will just be 0, this will be 0, and you're left with 5. So vertex form is nice because it kind of tells you, you can just look at it and tell what the vertex is instead of actually finding this negative b over 2a. So it is nice to have this form, but sometimes plugging in is actually easier to plug it in here. 2 minus 1 is 1, squared is 1, times 2 is 2, plus the 3 is 5. And then I'm going to just skip a little bit. That will be 11. So we're going to go ahead and just graph that. Again, this is kind of just a rough sketch here. And I'm not going to go up to the 11. I think the graphing part, once you get the points, the graphing part is pretty easy, just recognizing again what the shape of that graph is. So we've got 1, 3 is our vertex, 2, 5, and 0, 5. And so you can kind of see it there. Notice that both of the graphs that we've done so far open up. That is because the lead coefficient is positive. If A is less than 0, meaning it's negative, then it will open down. So this is something that's useful to note as well. All right, we're going to use a little bit more information about this, a couple of things. So this does open up because it has that lead coefficient that's positive. This also, we're going to talk about minimum versus maximum. This has a minimum value. It opens up, which means it has a minimum of, and the minimum value is the y value. So the minimum value, I'm going to write this as 1, 3. The minimum of 3 occurs at x equals 1. So you will see a couple of problems that ask you about the minimum maximum, and it will say, you know, the minimum is what? That's your y value, and it occurs where? That's your x value for the vertex. So it's just the lowest point or the highest point. If it opens down like this, then it will have a maximum. The vertex will be a max. All right. We're going to also find the domain and range. So the domain of this one, let's come over here. Domain If you recall from the previous lessons, domain is the x value, and we're going to write this in interval notation, so it's going from left to right. This graph will go on forever. In both directions, it'll go on forever. Kind of slowly as far as the x value goes. It's going to get bigger as the y value goes. But this is from negative infinity to infinity. And all of these will have that domain. They will go from negative infinity to infinity. The range, however, will depend on that minimum and maximum. If you notice, the lowest this graph goes, the y value, the lowest y value is at that vertex, which is 3. So it does include that 3, so it goes from 3 on up to infinity. If it was, and again, infinity is always that open bracket. If it opened down, then this would be flipped. It would be negative infinity all the way up to whatever that maximum point was, the y value of that. So that's domain and range. And then the only other thing to talk about is, with these, is what that lead coefficient means. If A is between negative 1 and 1, meaning it's a fractional value, so like negative 1/2 or 1/2, then the graph, it makes the graph wider. It becomes wider. And it might seem kind of counterintuitive to think, okay, but it's a fraction, why is it making it bigger? But it means that you're multiplying by that x squared. So like in this case, if this was a 1/2, if we plugged in 2 here, we get 1 squared times 1/2. It would actually, plus a 3, you get 3.5 instead of the 5. So it'd be like down here. So it'd kind of make it, it'd be going, the difference between the x values would be less. So it's kind of stretching it out. It makes it stretch and become wider. If A is greater than 1 or A is less than negative 1, the graph becomes narrower. So the graph will become narrower. And again, like if this was a 4, then, and we plugged in 2 here again, so the point at 2 was 5. So if we plug that in, we get 1 times 4, the 1 times 4 is 4 plus the 3 is 7. So this value would be 7. And so instead of right here, it'd be stretched up here and it'd be skinnier, it'd make it more narrow. So it kind of seems counterintuitive, but it makes sense when you think of it on the graph. Okay, so we just covered a lot about graphing, how to find the vertex, convert from standard form to vertex form, how to actually convert that to a graph having points on either side of that vertex. What the domain and range are, what the minimum, maximum are, how you tell if it opens up or down. Again, it opens up if it's a positive A value, down if it's a negative. And then what happens when the A is a fraction versus when it's an integer, or greater than 1, I should say, or less than 1, which will make it narrow. All right, so that is it for graphing functions. That was a quick little crash course. We covered a lot, but hopefully that will help. All right.